Okay, this is for Sarah. Vectors in the plane. You can read through this at your own, at your leisure. We'll just skip ahead. These are some formulas that are on your formula sheet that, Sarah, I think I forgot to give you. I'll give it to you when you get back. But you can just know that you can use the formulas. You don't have to memorize them. Alright, it says show that the arrow from R is negative 4, 2 to S, negative 1, 6, is equivalent to the arrow P equals 2, negative 1 to Q equals 5, 3. Okay, to show that two vectors are equivalent, basically we want to do RS and PQ. They need to have the same magnitude. So to find the magnitude from RS, the magnitude formula is really just the distance formula, x2 minus x1 squared plus y2 minus y1 squared. So that's just going to be, from R to S, is going to be negative 1 minus negative 4 squared plus 6 minus 2 squared. That's going to be 3 squared plus 4 squared, which is 25. The square root of 25 is 5. And then if we do PQ, the same thing with these two, you would do 3 minus, wait, why am I doing my y's first? Hold on, hold that thought. 5 minus 2, there we go, squared plus 3 minus negative 1 squared. That's 3 squared plus 4 squared. That's the square root of 25, which is 5. So they are equivalent. Okay, example 2. It says find the magnitude of the vector represented by PQ, where P is negative 3, 4, and Q is negative 5, 2. Again, that's the exact same thing we just did. The magnitude is just the square root of x squared x2 minus x1 squared plus y2 minus y1 squared. So that's going to be negative 5 minus negative 3 squared plus 2 minus 4 squared, which ends up being, plus that is 4, plus, that's 4. So it's the square root of 8, or 2 square root of 2. We could leave it as square root of 8. Either way. Vector addition and scalar multiplication. Just says that you can add vectors together or multiply vectors by a number. To add two vectors together, you usually add head to tail, or you can draw another triangle with them, or a parallelogram. To do u plus v, we just literally add u, negative 1, plus v, 4. Negative 1 plus 4, comma, v, or the y value is 3 plus 7. So that's 3 and 10. 3u, just take u and multiply it by 3. So it'd be 3 times negative 1, 3, and you just distribute it to both. So it'd be negative 3, 9. 2u plus negative 1v means you multiply 2 times u plus negative 1 times v. So that'll be negative 2, 6, plus negative 4, negative 7. That's negative 6, negative 1. Okay. Finding a unit vector, there's my formula. Basically, and I'll put it here, to find the unit vector, it's just the vector AB over the magnitude of V, which is the square root of A squared plus B squared, divided by its length, or its magnitude. So you just do negative 3, 2, divided by the square root of negative 3 squared plus 2 squared. So that's negative 3, 2, divided by, that's 9 plus 4, that's the square root of 13. So it'll be negative 3 over the square root of 13, comma, 2 square root of 13. And verify that as length 1. Well, if you do the length of this, you would do negative 3 over 13 squared plus 2 over 13 squared, which is 9 thirteenths plus 4 thirteenths, which is 13 over 13, which is 1. Yay, it's 1. component form of a vector is just the length times cosine, or the magnitude times cosine of theta, comma, the magnitude times sine of theta. And you can always remember cosine comes before sine. So find the components of vector v with direction angle 115 and magnitude 6. It's just 6 cosine of 115, comma, 6 sine of 115, and we still need to be in degrees. You end up getting 2.54 negative and 5.44. I only went to 2 decimal places. I should have went to 3. Oh well. And Sarah, I'm sorry, I'm going through this really fast, just so the video won't be that long. And just need to pause if you need to. It says find the magnitude and direction angle of each vector. Now, basically, to find the magnitude, hold on, look. The magnitude is just the square root of 3 squared plus 2 squared, which is 9, plus 4 is the square root of 13. So that's the magnitude. Now the direction angle, you plot it like you would a point. Go over 3 and up 2. Okay, over 3, up 2. And we got to find this angle here. Well, what can I do? Oh, look, that's opposite over adjacent. So you could just say tan equals opposite over adjacent. Do inverse tan of both sides. Give me an angle. And you get 33.69. So there's my magnitude and my direction angle. Okay, I would do this one the same way. Negative 2, negative 5, negative 2, negative 5. So I do tan of theta equals negative 5 over negative 2. So my theta ends up being 68.19. But here's the thing, that is 68.19, but I want my actual angle, so it's going to be this whole thing. So I would need to take that 68.19 and add it to 180. So you get 248.2 degrees. Alright. Okay. A DC jet aircraft is flying on a bearing of 65 degrees. Now, when we're talking about planes, bearing is always from north. You always start from your y-axis and go clockwise. Wait, clockwise is clockwise. Yeah, like a clock. Clockwise, that way. Whereas on your unit circle, you always start from here and you go counterclockwise. Well, bearing, you start from north and you go clockwise. So it says a DC jet aircraft is flying at a bearing of 65 at 500 miles per hour. This is just the length of the vector. Find the component form of the velocity of the airplane. So it's just going to be 500 cosine of 65, comma 500 sine of 65. That ends up being 453.15 to 11.31. Okay, and I'm going to stop this video now and go ahead and start another one for example 8. I think that will get you through the first day's homework. When you get to all the word problems, we're actually going to do a worksheet for that, and I'll tell you what that is after the next video.